Okay, setup of the project is still fairly easy, supremely easy. All you see here right now is I scrubbed some of the old images out of Docker. If you still have one of our projects set up from before, or if for some reason you have to run it up again, there is a Docker compose argument that rebuilds the images. I don't remember it. You can remove them with RMI. You shouldn't have to rebuild for any reason other than if you had the project ahead of time. Regardless, all you'll need ahead of time for Docker Compose is to have Docker and Docker Compose installed. Um, and I believe, fairly sure, all of that instructions of how to install that are in the instructions to instructor. But once you have Docker and Docker Compose installed, you just navigate to our root folder. Well, the folder with the Docker Compose YML file here. Yeah. And then run docker tac compose up, or sudo docker compose up on Linux. And this will actually, I'll give you a warning, will take a little while on slower machines. It could take up to 30 minutes, I guess. I'm gonna pause at some point in here. We're gonna skip most of this, and I will come back around when you'll be able to see here when the images actually start showing up. This is test images for it downloading base versions of could be Nginx, Node, anything. It gives them these every once in a while clever random names. And you'll see a few of these, or you would see a few of these appear and disappear as Docker Compose is running. Berkeley set this up for us. If you want to verify any of it, it's the Docker Compose YML file, does a few things on the top end, and then individually inside of each other folder, at least for our 6 Docker containers, there's a Docker file that gives some more instructions that are called recursively with Docker Compose. Now, and you see, we've got a new one already, something else. I could talk about the technologies a little bit right now, too. That's what the real struggle of this project was. There was not a whole lot of actual code to write, but a ton of figuring out APIs and making everything work together. We're using 2 different kinds of databases. We're using MongoDB for general storage. It's any authentication that's not through Google, I think, is the only thing other than our personal or local that we have set up. Oh, and the dashboards too are in Mongo. But then we're using InfluxDB for Grafana and for specifically for high volume traffic in a limited space. That is what it is built for. I believe even Grafana's website recommended it, Influx, and a few others. Then we're using 2 node servers, a back end and a front end. Back end moving data from MD2K, our simulated MD2K, and the front end serving the actual website. Then Nginx, we have a reverse proxy set up just for the purpose of authentication. I think Dr. Fleming had asked us about that idea too, of a reverse proxy, which, to elaborate on, the only difference in that and a regular proxy is the idea that a reverse proxy is the web server farming out some kind of processing somewhere else, which is what we're doing. We're farming out authentication, but then it comes right back to the node server. Then we have Grafana for actually displaying the dashboards. Grafana gives you a lot of tools to create visualizations out of data, viewing it over time frames really easily with it was either SQL or a MySQL, a little custom editor that they have. And you'll be able to see that too because it's all included with Grafana when you hook it up to your server. And then lastly, Docker. Probably most importantly, Docker gives you a system of virtual machines, little isolated virtual machines. So we essentially have a VM running every piece of our project, every one of those technologies that I just listed. And from the developing side, it's remarkably easy to set up these Dockers to do various things for you too, and then to communicate with each other.